Elementary transformations, find the inverse of the following matrix. I have already discussed with you that using elementary row transformation, how to find the inverse of a second order matrix. You know, we start writing A equal to IA, and like in the present case, the value of A is matrix 4, 5, 3, 4, and this being a second order matrix, we will also take I the identity matrix of second order 1, 0, 0, 1. Now before I proceed further with the elementary row transformation, let me revise with you the steps I am going to take it. You know, if A is in general say A11, A12, A21, A22, then in step 1, we reduce this A11 as 1. Then step 2 will make this A21 as 0. Then in step 3, we'll make A22 equal to 1. And finally, in step 4, we'll make A12 equal to 0. That will be the procedure. Though I discussed with you when I was teaching you in the beginning how to find the inverse of a matrix using elementary row transformations, you can check from there also. Now let me take the present sum. It is a simple question. In row 1, A11 here is 4 and you know A21 is 3. So by applying R1 minus R2, it will reduce to 1. So replace R1 by R1 minus R2. You get 4 minus 3, 1, 5 minus 4, 1, keeping the second row same and apply the same transformation on the right side. Never forget to do that. So R1 minus R2, the 1, 0 minus 1 will be minus 1 and the second row will remain the same. Continue to write A as such. Now, the first step we have got that A11 we have reduced to 1. Now how to reduce? A to 1, that is the 3 to 0. So 3 minus 3 times R1. So we'll replace R2 by R2 minus 3 times R1. So applying that, keeping the first row as such, and R2, that is 3 minus 3 times 1 will make it 0. 4 minus 3 times 1 will reduce it to 1. Applying the same on the right hand side, keeping the first row same, that is 1 minus 1 will remain the same, and 0 minus 3 times 1 will make it minus 3, and 1 minus minus plus 3 will make it 4. A you continue to write. So now we have got 1, 0, 1 is by the way automatically there, and it is easy to reduce this A12 by 0. How will you do it? Just apply R1 minus R2. So in the next step you replace R1 by R1 minus R2. So 1 minus 0 is 1, 1 minus 1 0, keeping R2 the same. On the other side, 1 minus 3 will make it plus 3, that is 4, and minus 1 minus 4 will be minus 5, and keeping the second row as such, minus 3, 4, and A you continue to write. So now we have got the required form, that is I equal to, here if I call it B, A. So this implies that A inverse, the required inverse is B, which we have determined as 4 minus 5 minus 3, 4 is the required value of A inverse. Now, question 9, you try yourself. This is almost same as question 8. So I leave for you to try question 9. Now next question 10, you have to find the inverse of the matrix 3 minus 1 minus 4, 2 using elementary row transformation. Now there is nothing new in this, but how to make this A11 equal to 1. One way that you multiply row 1 by 1 by 3. 3 into 1 by 3 will be 1, but as I keep telling you, then will involve fractions which will create problem later. Let me write, I'll tell you how to do it. To find the inverse, how do you proceed? We write the first step, A equal to IA. What is the value of A here? 3 minus 1 minus 4, 2. And I will take identity matrix of second order, that is 1, 0, 0, 1, and continue to write A as such. Now, to reduce it 1, if I add R2 plus R1, that will give you minus 1, but that will be in the second row. So it is better, first you interchange R1 and R2. What do you get? By replacing R1 and R2, you get minus 4, 2, and in the second row you get 3 minus 1, and on the right side you get 0, 1 and 1, 0 in the second row, and continue to write this. And now we have got minus 4, but I would like to make it plus 4, so multiplying R1 by minus 1. So R1 to be replaced by minus 1 times R1, you get 4 minus 2, keep the second row as such, so you have 4 minus 2, 3 minus 1. On the right side also, multiplying by negative 1 to row 1, you get 0 minus 1, 1, 0, A, continue to write. And now it is easy. Now it is as good as question 8, you have 4 and 3. So replacing R1 by R1 minus R2, A11 will become 1. So applying R1 minus R2, you get 1, and minus 2 plus 1 will make it minus 1. Rewrite the second row as such. Similarly on the right side, 0 minus 1 will make it minus 1, and minus 1 minus 0 of course will remain minus 1, 1, 0. The second row as such, A, you continue to write. And now, you see, we want to make this A21 equal to 0 with the help of A11, remember, with the help of A11. So 3 minus 3 times 1 will make it 0. So replace R2 by R2 minus 3 times R1. You get 1 minus 1, 0, 2, and on the right side you get minus 1, 4, 3, A, we continue to write. So now we have got 1, we have got 0, and now we want to make this A22 equal to 1. And for that, you multiply R2 by half. So replace R2 by half the times R2. Multiply the elements of R2 by half. So you get 1 minus 1, first row as such, and the second row will become 0, 2 into half will make it 1. Similarly on the right side, minus 1, the first row as such, and second row 2 into half will make it 2, and 3 into half, 3 by 2, A, we continue to write. And now we want to make this element, which is A12 equal to 0, and which is simple, you add R1 plus R2. So replace R1 by R1 plus R2, you get 1 plus 0, 1, and this will become 0, and of course 0, 1. So we have got I on the left side. Applying the same on the right side, minus 1 plus 2 will make it 1, minus 1 plus 3 by 2 will make it half. Write the second row as such, ending. So now we have reduced the question in the required form, that is I equal to BA. So obviously A inverse is B, which we have called as 1 half 2, 3 by 2. So finally, what is the required value of A inverse? A inverse is 1 half 2, 3 by 2. So that is the required value of A inverse. Now question 11. This looks simple. In the first row, you have 2, in the second row you have 1. So just by interchanging, A11 will become 1. But before that, let us write the very first step to find the A inverse. First of all, we write A equal to IA. In the present case, the given matrix to which I am calling A is 2 minus 6, 1 minus 2, and I, a unit matrix of second order, is 1, 0, 0, 1 times A. Now you just interchange R1 and R2 and your A11 at place for A11 you will get 1. So you get 1 minus 2, 2 minus 6. On the right side also you interchange R1, R2, 0, 1, 1, 0. Continue to write A as such. And now we have of course got this one, how to reduce this A to 1 equal to 0. 2 minus 2 times R1. So here we apply, replace R2 by R2 minus 2 times R1. Continue to write R1 as such. So 2 minus 2 times 1 will make it 0. Minus 6 and minus 4 plus 4 will make it minus 2. Likewise on the right side, you rewrite R1 as such, and 1 minus 2 times 0 will continue to keep it 1, but 0 minus 2 will be minus 2 and A as such. And now we want to make this A to 2 element equal to 1. How can you do it? Multiplying R2 by minus half. So replace R2 by minus half times R2. Multiply each element of R2 by minus half, keeping the first row as such. You get 0 minus half into minus 2 will make it 1. Similarly on the right side, 0, 1 as such, and you get minus half and 2 into minus 2 half will make it 1. Now finally we want to make this element, which is A12 equal to 0 with the help of this one, A22. So it's easy. To R1 you add 2 times R2. So R1 to be replaced by R1 plus twice R2. So you get 1, 0, 0, 1 is already there. Similarly on the right side, 0 plus 2 times half will, minus half will make it minus 1. The next element will become 3 and the second row will remain intact. So now we have got it in the required form, that is I equal to BA. So obviously A inverse is B, and the value of B we determined as minus 1, 3 and minus half 1. So this is the required value of A inverse.